Okay, we are live. Hey guys, good morning, greetings of the day. Thank you so much for joining. In today's session, we'll be discussing about getting started with algorithmic complexities. So let me introduce our speaker, Mariam Mirza. Mariam, welcome. Would you like to introduce yourself?
Hello everyone, greetings of the day. My name is Mariam and I'm doing BTech in Data Science in Kashmir University. Today I'll be having a session on algorithmic complexity. So let me start by sharing my screen. Is my screen in share?
Yes, your screen is in share. The floor is all yours. I'll pull myself off the stream. I'll be in the back stage. Uh,
Okay, thank you. So let's get started with our session. Our today's session is on getting started with algorithmic complexity. So I'll start by giving an overview of what algorithmic complexity is, and we'll also see some of the related code examples in different languages like Python, JavaScript, TypeScript, and C Sharp. So for that, the software or tools you'll require is Visual Studio Code, Node.js, Python, and .NET. Again, I'm still a learner, so I apologize if I make any mistakes. So, this is our agenda for today. We'll start by giving an introduction to what algorithmic complexity is. We'll see some of the algorithmic complexity notations like big omega, big theta, and big O. We'll understand some of the big O notations and some of its basic concepts. Then we'll move on to some of the common time complexities, like we have big O of 1, which is constant time, big O of log n, which is logarithmic time, big O of n, which is linear time, and big O of n to the power 2, which is polynomial time. So you can refer to my documentation for the source code of today's session. So fasten your seatbelts and let's get started. This is our big picture for today. So let's start by understanding what algorithmic complexity is. So as we know, there are several ways to write the code, and we need to always find the best way to write it. Because the efficiency of our code matters, we need to know how our program is going to perform. So this is how when we are going to use algorithmic complexity. So algorithmic complexity shows us the computational resources which are going to be used by our program. There are two parts to algorithmic complexity. One is a space complexity, which is the amount of space or memory required for your program to run. And the other is time complexity, which we'll be talking about today. So, time complexity, there is a common misconception that time complexity refers to the runtime of the code, but it is quite possible that the same code will have different execution time in different systems. So, time complexity does not refer to the actual runtime of the code, rather, it is based on the number of instructions or operations to be executed. Now, when we are writing the code, we can have a good code, we can have average code, and we can also have some horrible code. So, how do we measure this? There are three ways to measure this. We use algorithmic complexity notations to measure it. We have big omega, big theta, and big O. So, when we are talking about big omega represents the lower bound of the algorithmic complexity, which means that it is going to be the best case. It always shows the best case performance of the algorithm, and it takes the shortest amount of time to run. And when we are saying that the some algorithm has the time complexity of omega n, it means that the best case running time is growing linearly with the input size. So big omega is used for understanding the lower bounds and the best case scenarios. Then we have big theta. So big theta will represent both the upper and the lower bound of the algorithmic complexity. So this will show the tightest possible bound for your algorithm's performance. So now if you're saying that some algorithm has the time complexity of theta n, it means that both the best case and the worst case running time is growing linearly with the input size. So this is used when we want to express the precise estimate of an algorithm's behavior. You can also say that big theta is the average case. Then finally we have big O. Big O is the most important one. This is what will be asked most of the time. So you need to remember that big O is always going to be the worst case scenario. So big O will help us understand the upper bound of the complexity. So this shows how the algorithm is going to perform when the input size is growing. So this is what is going to be the most important thing. And if you're saying in big O, the worst case running time is growing linearly with the input size. And it is used to analyze the worst case scenarios. We always need to be prepared for the worst case. So now moving on to some of the common time complexities. The first one we have here is big O of 1, which is constant time. So you can understand from the name itself that this is going to execute in a fixed amount of time, regardless of the input size. So no matter how big your input size is, it's always going to take the same amount of time. So one of its example is accessing an array element by its index. So here we have some code. So let's see what we are doing here. We are going to be accessing an array element by its index. So here we have an array named student names, and we have some name of the students, and we are creating a function named show name at. So here what we are doing is we are taking the array of the students and the index. So when we are saying that if index is less than 0 and index is less than the length of the array, so it's going to say that it will take the student at the given index, else it will give an error. So now if we see here, we are giving this array and we are accessing the 10th element over here. So when we run this, it is going to access the 10th element. And now here, if we increase the elements, if here I think we have around 18 students, but if we increase it to 20 elements, it's still going to take the same amount of time because it is always accessing only the 10th element. If we increase it to 50 elements, 100 elements, 1000 elements, it does not matter because it is always going to be accessing only this 10th element. So let's see how to execute this in Visual Studio Code. I actually have the code over here, so I'll just show how to execute it. Here we have this code. So what we are going to be doing here is we will open the PowerShell. Just a second. Okay, so let me first copy the path where our code is. Okay. So let's run this. So to run the JavaScript code, we need to write node main.js. So you can see that we are accessing the student at 10th element, which is Kevin. I'll quickly show you how to execute it in the different languages. So let's see the TypeScript one. So for TypeScript, you need to write ts node main.ts. So you can see here we are getting this error because what we are accessing the 41st element and the 41st element is not there. So as you can see, it's going to be just one execution. We are not going to be executing again and again, only one execution. That's why it's known as constant time. Then again, we can see the Python code. So for Python, we have python main.py. So we are again accessing the 41st element, which is out of bounds. Then at last we have the C# code. So we need to see where we have our project in this. So let's just copy the path directly. And then for this, we'll write .NET run. So it's accessing the 17th element over here. So this is about the constant time. Now I want to show you one thing, which is Big O cheat sheet. So you should remember this website. We have this graph over here, which is showing the elements and the number of operations. So it has categorized these time complexities into different sections. Like we have the red one, which is horrible, and we have bad, fair, and good, and excellent. So we can see that it is showing that as the elements are increasing, the number of operations, how it is going to be affected. Big O of 1 is over here. So it is when the elements are increasing, it does not matter if you have 10, 100, 1,000, 10,000, 1 lakh, it does not matter. The operations is going to be only one operation all of the time. So that is why this is considered in the excellent category. Now you can be wondering, if big O is the worst case, then how does this come in the excellent category? So what this is, in the worst case, it is still the better kind of code. Then after that, we have big O of log n, which is known as logarithmic time. So this, what this is going to do, it is going to, we also call it divide and conquer. So this is going to break our problem into smaller parts. So we are like kind of dividing and then completing the problem. So one of its example is binary search. So let us see how binary search works. What we are doing here is that we have this array of numbers. You can see that we have the sorted array, and we are going to be finding the number 9 in this array. So what is happening here? We are creating a function named binary search, which is taking an array and the target number. So we have this left, which is the number at the index 0, and the right, which is at the rightmost end. So what is happening is we are creating a while loop. When left is less than or equal to right, then we are finding out the middle of this whole array. So left plus right divide by 2. So here we have 1, 2, 3, 4, 5, 6, 7, 8. So since it starts from the index number 0, so this will be 0 and this will be 7. So 0 plus 7 divided by 2 is 3.5, but since we have math.floor, so it's going to take 3. So the index at element 3, the element at index 3 is 12. So it's first going to take the 12th and this 12, and then it's going to see if it's equal to the target. Here we are searching for 9. So this is this is going to not return true. So we'll go to else if. So here we are seeing again, we'll check if this 12 is less than the target or is it greater than the target. So since here it is less than the target, we are going to go mid plus 1. So we are going to go here, and here we are going to find our element. But since it's big O, we are always going to be considering the worst case. In big O, we are considering that the data sets we are working with are very large. They're almost touching infinite. So here we are going to be assuming that if we have to access the last one or the first one, so that is going to be the worst case. So here we are completing this in 2 operations, but usually we consider the worst case. So let's see this in here. We have second, we are doing big O of log n. So here we have this code. So we are going, let's just start by C#. Let's copy the path. And now we'll do .NET run. So you can see that from doing the binary search, we are getting that it is at the index number 2. So again, we have the other code also this way. So I can quickly show you how to execute all of them. Let's move on to JavaScript. Then we'll do node main.js. So it's again showing that it's at the index number 2. Then we'll move on to TypeScript. So here we'll do ts node main.ts. It's showing that the element 9 is found at the index number 2. We'll also show in Python. So here we'll write python main.py. So this is also showing us the code. So now let's check here where this falls. So we have this big O of log n. So it's falling somewhere between the good and excellent category. So what is happening here is that For example, we have 100 elements. So if we do log of 100, so we get 6 operations. So we have 100 elements, but we are completing it in 6 operations. Now if we have 1,000 elements, its log of 1,000 is 10. So we'll complete we'll see if we have 1,000 elements, we are going to complete it in 10 operations. So this way it's going to help us complete our operations in very less time. Then moving on, we'll see big O of n, which is also known as linear time. So what this is going to do is that the running time is growing linearly with the input size, which means that it is proportional to the data set. So what I mean by this is that let's see an example looping through an array. So we have this array and we are looping through it. Imagine if we want to access the last element. So we are going to loop through each and every element. We are going to go from 0, 1, 2, 3, 4 till the last one. And when we are considering very large data sets, so it's going to take a lot of time. So a lot of operations actually. Let's see where this falls in the graph. So we have big O of n. So here it is falling in the fair category. When we are increasing the elements, the operations are also increasing. So you can see that when the elements are getting increased, the operations are also getting increased. So let us see this code, what we are doing here. We have these student names and we are we are looping through these students actually. So this is one of the example of looping through an array. Let us quickly execute them. So we are doing big O of n. So let me copy the path. And then let's see JavaScript. So node main.js. So you can see that we have all of these elements and all of these students, which we are looping through them. Let me just clear the screen and then we'll move on. Now let's see in TypeScript. So here we are going to write ts node main.ts. Here also we are looping through all of them. So the same way you can do it also in Python and C#. Then moving on, we have big O of n to the power 2, which is known as polynomial time. So one of its example is nested loops. So when we have nested loop, it is big O n to the power 2. So it is going to fall, let's see where it falls. It's going to fall in the horrible category. So this is the worst way of writing the code, and you need to make quite an effort to write this horrible of a code. So let us see one of its examples. Bubble sort is one of its examples. So here what we are doing is we have this code, which is show names. So we have this students' names over here. And what we are doing is first we are looping through each student and converting it to uppercase. So we are going to be looping through each student over here. And then we again have a for loop in which we are looping through all of it again. Another example we have here is display coordinates. So we are giving the size as 8. And what we are doing here is we are starting from 0. We have kept I as 0 and I is less than the size. And then we'll increase it with 1. And then we have another loop here, which is the nested loop. We are keeping j equals to 0. And then we are incrementing it in every loop. So what is going to happen here is we are going to be starting and then we are displaying I comma j. So here we are doing 0 comma 0, 0 comma 1, 0 comma 2, 0 comma 3 till 8. And then this way we completed 0, then we'll go to 1, 1 comma 0, 1 comma 2. So this is going to like 8 to the power 2, which is going to take 64 operations. So this is the worst way of writing the code. Now let's execute this and see where we have this code n to the power 2. So let's copy the path. Here we'll write .NET run. So you can see that here first we have that example of the students. So we are looping through the array once, and then we are looping through it again. And then here also you can see that we have this. We are going 0, 0, 0, 1, 0, 2 till the eight times, but which is actually the index number 7. So this way we are doing it for 0, for 1, for 2, for 3, for 4. So this is quite the worst way of writing the code. Now let's see it in other languages also. So here we are going to, let me clear the screen so that you can see it. Then we'll see the JavaScript one. So let's write node main.js. So we are looping through all of these students. Then we are going to move on to the TypeScript one. And here let's write ts node main.ts. So again, we are looping through all of them. And also lastly, we'll see Python code. Python main.py. So we have this, we are showing the big O of n to the power 2. So after this, I want to show you guys some of the other tips and productivity tools. So if you don't have this JavaScript installed in your computer, so what you can do instead is that you can open a new tab, and then you can click on inspect. And here you can see that we have these options. So we are going to go to sources. So here we have snippets, and in snippets you can just add a new snippet, and then you can write the code. So let's see how to run this code. We have this hello world over here, and it is having a function named output string message. So it's going to just output hello world. Let's see how to run it. So you can see that here we are having this hello world. So even if you don't have JavaScript, I mean, you don't have Node.js installed, so you can just directly do it from here. Now, another of the things which I want to show you is, we'll just open a new PowerShell. I want to show you some of the kind of commands which you can use. So let's start by seeing, if you want to see some of the information of this. Okay, so you can see that whatever .NET SDKs you have installed and all of the different information. Now, if you specifically want to see what SDKs you have installed, so you can write .NET list.sdks. Okay, so maybe I misspelled it. .NET list.sdks.
List hyphen.
Okay, so that, okay, sorry. One hyphen?
Hyphen. List hyphen SDKs. Hyphen list hyphen SDKs.
Okay, so yeah, so you can see which SDKs you have over here. Then we can also see some of the, we will write .NET new. So we have some of the templates which we can use in C#. So we have just a few over here. So if you want to see the whole list, you can write .NET new list. You have all of the list of the templates you have here. Usually we use console app, and you can have it in C#, F#, and VB. So the default is going to be C#. Then moving on, we have one more thing. If you want to create, let's see, .NET new console help. So this is going to give you all the information about the console app. You can see the name and where it's going to, and the location where it's going to bring the output, and the framework also and the language. It's like C# is the default one. So, but you can also specify that. And then moving on, we have .NET Console first sample. If you want to create a project named first sample, okay, just a second.
Clear the screen, please. .NET new space console space the parameter.
Okay, so this is how you can create a console app. Now, if you want to move to the console
Show
app
the
with this,
dry run. Mariam.
okay, so
That is good. Create a sample too and show the dry run and compare between with dry run and without dry run. Thanks.
so this is, we can see the dry run. So I don't remember the command actually. Let's just move on to the first sample. So I'll show you how to execute this using VS Code. So we have this program.cs, which has this one line named console.writeLine hello world. So if you want to see how to execute this, we have three ways how to execute this. So first is we'll go to the solution explorer, and then we have this first sample over here. We can click on it and go to debug, and then we'll go to start without debugging. So this is going to run our program. So you can see that we have executed it. It says hello world. The second option is you go over here to run and debug, and then you select this, the debugger. And you can see that we have executed this. It says hello world. The third way which you can do is open it in the terminal and just directly write .NET run. So this is going to show hello world. So let's summarize what we did today. We started by seeing what algorithmic complexity is and some of its notations like big omega, big theta, big O. We also saw some of the common time complexities, and we saw them on the graph as to how they are categorized. So we saw big O of 1, which is constant time, and then we saw big O of log n, which is logarithmic time, big O of n, which is also known as linear time, and big O of n to the power 2, which is known as polynomial time. So I think this was all for today. So hope you liked the session. Thank you for attending.
Thank you so much, Mariam. This was a wonderful session. Guys, thanks for joining, and see you again in the next event. Bye.